Hello, everyone. Thank you for tuning into our webinar on securing personally identifiable information, best practices for FinTech and FinServes with Postgres. I'm Annie, your host, and today I have Umair Shahid with us, who is the founder of Stormatics, as the speaker for this session. So before we dive in, a few housekeeping items. This webinar is being recorded, and of course, you will receive the recording along with relevant materials at the end of this session. We will have a Q&A session at the end of the webinar, so please feel free to submit your questions at any time using the chat function or again the Q&A feature. We'll do our best to address as many as possible during the allotted time. The rest of them will be answered in our post-webinar blog. Thank you again for joining us. Without further ado, I will hand over the controls to Umair. Thank you, Umair, and good luck.
Thank you, Annie, and thank you everyone for joining in. This topic was chosen because it feels like the financial technology and the financial services sector is a big fan of Postgres. We've found the Postgres use to be pretty dominant, especially in greenfield applications. And what I wanted to do was to try and understand what specific concerns the financial services sector has in regards to the use of their database. And one of the primary factors that came to my attention was how to make sure that personally identifiable information is secure in the database. And not only is it secure in the database, that it is unreadable and unbreachable, even in the case of a security lapse, even in the case data is stolen. So that's how we came up with this topic. What we're going to do is we're going to talk about different features in Postgres that we can leverage in order to secure PII. Now, what is personally identifiable information? As the name says, as the term says, it's data that can be used to identify an individual. And some examples of that information are name and passport number, address, phone number, driver's license, medical information, et cetera, et cetera. This is not a comprehensive list. These are examples just to give you an idea of what kind of information needs to be labeled under the PII and secured. Now, why is this so important, and what is so special about PII that is not relevant to other kinds of data? PII can be used for fraud, for violations of privacy, and perhaps more alarmingly, for identity theft. What that means is that if a criminal gets access to your personally identifiable information, they can use it for malicious intent and malicious purposes. It also means that if hackers get access to a large chunk of PII from an organization's database, they now have a wealth of information that can be used for fraudulent activities. It's also because of this very reason, because it is so critical for the protection of individuals, that lots of laws and regulations exist pretty much all over the world that govern the usage of how you store data inside your database and how that data is used. An example list of such laws and regulations is listed over here. So, you got PCI DSS, which is payment card industry, data security standard, SOC 2, HIPAA, which is related directly to the healthcare industry. GDPR is an EU regulation that protects privacy rights of individuals. ISO 27001 is a security standard for ISO. DORA is an act that's coming into effect in January of the coming year of 2025, and it will govern most of EU. NIST and FedRAMP, they're US specific laws and regulations. But this is just to give you an idea that there are lots of laws and regulations that protect personally identifiable information, and you need to abide by these laws and regulations. Now, to an organization that stores data, what are the risks in case of a breach? One obvious risk is financial losses. In case of a breach, you will need to contain the damage, and that will incur a direct financial loss. There will be legal fees because probably you're going to be hit by lawsuits. You will need to compensate the impacted customers as well. That adds up to a lot of financial loss. The reputation is damaged, sometimes irreparably. The brand is harmed, and the loss of customer trust is huge. That also compounds the financial losses in the medium to long run. The regulators, we just talked about a lot of laws and regulations that are prevalent in this sector. There are humongous penalties associated with such a breach in case something like that happens. And then, of course, in case of a breach like this, the operations are disrupted, and business as usual is no longer possible because of it. In order to secure personally identifiable information in Postgres, we're going to cover 4 aspects. These are, encryption of the data, authentications of users, access control, and audit trail. And we're going to go through this one by one during the course of this session, of this webinar. First off, let's talk about encryption of data. What is encryption? It's the process of converting data into a format that can be read only if you have an appropriate key available. Think of it as a lock that can only be opened if you have the right key to it. So anything behind the lock is secured. It's only people with the key that can unlock the door and get access to whatever is behind that closed door. So encrypting of data is something similar to that. And how do you encrypt data, or where do you encrypt data? You need to encrypt data when it is in motion. Motion means that it's flowing through the network, and it is going either over the internet or your local network, or connecting different sites. As data flows through the network, it needs to be encrypted and protected. That's data in motion. And then there's data at rest, when it's residing in the database, residing on disk. You need to make sure that it's protected and encrypted. Data in motion, encryption of data in motion is achieved using TLS protocols. TLS stands for Transport Layer Security. And encryption of data at rest is achieved in one of 3 ways. The first is disk level encryption. The second is encryption of specific columns. And the third is transparent data encryption, or TDE. And we're going to go through each of these types of encryption, both in motion and at rest, in the next few slides. Now, implemented encryption for data in motion. It's done using an SSL certificate, and it uses TLS protocols. SSL stands for Secure Sockets Layer, and TLS, as I mentioned in the previous slide, stands for Transport Layer Security. And essentially, for implementing encryption of data in motion in Postgres, the steps that you need to perform, the very first step is generating the SSL certificate. There are authorized vendors that you can buy these certificates from. These will verify the authenticity of your existence and before issuing the certificate. And once you have it, you can use it in Postgres and other areas. Then you need to modify the config files in Postgres to enable SSL connections. And these right here are a few steps. You need to turn SSL on. You need to specify the path to the certificate file, to the key file, and the certificate authority file. And for every client that is connecting to this database, you need to enforce SSL connections. So if you go into postgres.conf, for host SSL, you need to specify the certificate to set the client authentication method. And what Postgres will do once you have enabled this thing right here is that it will force all clients to establish their connection via SSL. Now, next up is encryption for data at rest. Now, the first possibility is to do a disk level encryption. Now, what this does is it encrypts the entire disk that is hosting not just the database, but everything on that system, everything on that machine. It could be the operating system, this could be any other software that you've installed. Everything is going to get encrypted on disk if you enable disk level encryption. Now, because this is at the level of the disk, it's handled by the operating system, and it is outside of the scope of the database. So this slide right here that you see in front of you, this is not Postgres specific. This is applicable to absolutely any application and absolutely any OS. In Windows, the functionality is BitLocker. For Mac OS, it's File Vault. And for Linux, it's LUKS, which is Linux Unified Key Setup that you can use to encrypt the entire disk. A few key considerations before you encrypt the disk. Make sure that you back up your data because the process of encryption is invasive and you want to make sure that it gets through successfully before you can start relying on it. And in case something goes south, you want to make sure that you have a backup. Keep in mind that encryption of data impacts performance. If you are encrypting your disk, your operating system is going to be encrypting every piece of data that goes into the disk and decrypting every piece of data that comes out of the disk. And that process of encryption and decryption impacts performance. And it's absolutely critical. I think it goes without saying that you have to keep your encryption keys and passwords safe because without that, you will lose access to your entire disk. The next step or the next possibility of encryption for data at rest is column-based encryption. And you can achieve column-based encryption in Postgres using an extension called pgcrypto. It's a very popular extension. It's been around for a very long time, very reliable, been used in production databases very reliably, pretty much all across the world. Now, the key steps in order to use pgcrypto is, well, first of all, you need to enable the extension. And then you can create a table with column that needs to be encrypted. And there are functions that this extension provides. This is, right here, PGP sim encrypt is a function that will encrypt data based on whatever password you choose. So the syntax is that you pass the data that needs to be encrypted into as a first argument, and the second argument is your password, and the function will return an encrypted piece of data. In order to decrypt it, there's another function by the name of PGP sim decrypt, and it's the exact same thing, just in reverse. You, as a first argument, you give it the field of the table that needs to be decrypted, and you provided the password, and the function is going to return to you the decrypted data. And if you want to update the data, you use the same encrypt function in exactly the same way, and you will be able to update the data in the table, update the encrypted data in the table. This is specific to a column. Each time you enter data, you retrieve data, you will need to encrypt and decrypt. You want to make sure that these functions are used and used reliably. It does rely on a password, and you need to keep that password secure somewhere. And inside of this particular function, this password is passed in plain text. So anybody who views this function, or if you're writing an application that uses this function, the password is going to come in plain text. So keep that in mind. Finally, for data, for encryption for data at rest, we've got transparent data encryption, or TDE. Now, the key concept over here is that it encrypts all of the data in the database. And it's not just the tables, it's also the actual data files that reside on the operating system or on disk, and all the write-ahead logs, because Postgres relies heavily on write-ahead logs, not just for keeping the data and writing to disk, but also for replication and for failovers and clustering. So it encrypts all of the data. TDE does that, and it ensures that even in case of something as drastic as a disk being stolen, the data is still encrypted, and nobody can decipher it or use it for malicious intent. Now, Postgres natively does not provide TDE functionality. There are forks available, and it is offered as a proprietary product. There are different vendors out there that provide TDE in case that is needed by your organization. Now, the transparent in TDE refers to the fact that when you're writing to the database or when you are reading from the database, the encryption and decryption are absolutely seamless and transparent to the user or the application that's doing the reading or writing. Compare that to PG Crypto, which in which you specifically need to call a function to encrypt and decrypt data. In this case, it's absolutely transparent and seamless. It has an architecture that's a two-tier key. The first key is called the DEK, which stands for Database Encryption Key, and that is used to encrypt the data. And then there's an MK, which is the master key, which encrypts the DEK in turn. It's seamless, and these keys can then be integrated with third parties, like, for example, FileVaults or HashiCorp kind of an implementation where you have data vaults that can keep the key secure, and the entire end-to-end process can be completely automated and can be ensured without human intervention. TDE tends to be the most secure and the most robust. This is also the type of encryption that satisfies most of the regulations and acts that require that companies need to comply with. Summarizing encryption of data, you need to encrypt data both in rest as well as in motion. For data in motion, TLS protocols are used. For data at rest, you use either disk level encryption, column-based encryption, or transparent data encryption. So that brings us to the end of encryption of data. Now, the second topic that we're going to cover in securing PII is user authentication. What is user authentication? It's a security mechanism that checks that it's a valid user that's trying to log into the database. So it is like the guard standing at the gate that is verifying the credentials of the user trying to get in before it allows the user in. In case the credentials are valid, the user is allowed in. In case it's not valid, the user is refused and access is blocked. Oops, I think I skipped a couple of slides. Sorry about that. The kind of authentication methods that are available in Postgres, it's a big list. There are different kinds of authentication methods that are available. I've listed 10 over here, and I'm going to go through these 10 authentication methods one by one, and I'm going to try and go through them quickly because at least some of them are very similar to each other, and I don't want to waste too much time delving into them. But there are a bunch of authentication methods available, and the point over here is that you can pick and choose what you want to use in Postgres. The first one is trust authentication, and that's the default when you install Postgres. That is what's there out of the box. It allows all connections. It allows all connections without specific verification. This can be used in development environments where security is not critical, ease of use is a priority, speed is a priority, and you can trust people who are connecting to your database. It has to be limited to non-production environments, however, because in case you roll something like that out in production, and it's still kind of trust authentication, there can be malicious actors who log into the database and steal the data, disrupt the data, leverage it for malicious intents. Sorry. The next is password-based authentication. So essentially what it does is when a client asks for a connection to the database, it asks for a password and allows the client to connect only if the password is verified. And there are different types of passwords that you can use for a password-based authentication in Postgres. The first is plain text. That's fairly simple, and that's also the default if you enable password. You type in the password, the Postgres server verifies it and lets you in. In case of MD5, if you set it to MD5, it's MD5 hashing that is used during the transmission of the client connection. So you type in the password, and during transmission, MD5 hash is used, and Postgres can understand that hashing and can verify whether you are a legitimate user. So this is more secure than the plain text authentication or plain text password. Now, the most secure out of these all is the SCRAM SHA-256 authentication method. SCRAM stands for Salted Challenge Response Authentication Mechanism. This has been around in Postgres for a while, and it uses 256-bit encryption and does a sorted challenge response. So essentially, it adds what is called a salt in the password string to make it unique to that particular instance. So even if there is a reference hack available to potential hackers that are trying to breach into the database, the server is going to present them with a salted challenge, and they will not be able to overcome that challenge, unless they have, something that is going to break open a 256-bit secure, password, which, well, mankind hasn't really invented yet. So it's very secure and is the way to go in case that you have a higher security requirement. So password-based authentication is suitable for most environments. Database security is needed in most production environments, and that's where it's suitable. And it can also be used with applications, not just users individually that are connecting. It is best practice to enforce the use of strong passwords. So you can define, a combination of uppercase and lowercase, a combination of numerics and strings, special characters, etc. Ensure that TLS is used to encrypt passwords for connection. So as the passwords are in motion, they are encrypted. Keep in mind that plain text passwords are the least secure. MD5 is more secure than plain text, and SCRAM SHA-256 is the most secure. Moving on, GSS API authentication. GSS API stands for General Security Service Application Program Interface, and it uses the Kerberos protocol for authentication. Essentially, Kerberos is where single sign-on is needed. There's a central authentication mechanism already in place with the enterprise, and that's Kerberos based, and Postgres can integrate with that and use that same SSO to authenticate the user. The best practices over here are to make sure that you're securely managing your key tab files and that you integrate with the existing infrastructure for seamless authentication. SSPI, very similar to GSS API, but for Windows. SSPI stands for Security Support Provider Interface. Again, the use case is very similar to GSS API, but just it's focused on Windows. If you have a centralized verification requirement on Windows, you can use SSPI authentication. Best practices again are very similar to what we had in the previous slide. You want to make sure that you leverage an existing Active Directory setup for any seamless authentication for Postgres. So Postgres can help you integrate with SSPI. Active Directory as well. Sorry. Next up is ident authentication. And what it does is, again, a central means of authentication, but it uses the client's operating system to verify the connecting user. So essentially, when you try and connect using ident authentication mechanism, Postgres will ask the OS to verify the user that is connecting. And if the OS says it's all good, Postgres will allow the connection in. So it relies on the ident authentication of the client's operating system. You can use it in controlled environments. You need to be able to trust the client machine to give you the right authentication. But the best practice is that you limit this kind of authentication only to IP addresses that you know and that you trust. Peer authentication, it's similar to ident, but it does not cut across network. It is focused on local connections only. So on the same machine, if it's on the same server and the client is connecting from the same server, peer authentication gets the verification from the host OS of that same server. The best practice is to restrict the usage for local connections only and to ensure that the Unix users that you create on the host OS are secure and well managed. Next up is LDAP authentication. LDAP stands for Lightweight Directory Access Protocol. And what Postgres does is it uses the LDAP server to authenticate the users for centralized management. Again, this is another form of centralized management. The use cases are where you have an existing LDAP infrastructure and you want to integrate your Postgres authentication with the existing infrastructure. Best practices include making sure that LDAP authentication is used over a secure protocol. So LDAP-S is used using SSL or TLS. And this is standard practice for pretty much all protocols, but especially pointing out over here, make sure that you regularly update and maintain all of the configurations of your LDAP server. Moving on, Radius authentication. Radius stands for Remote Authentication Dial-in User Service. Once again, centralized authentication. This time it's a client-server protocol. If your organization already uses Radius for authentication, you can integrate Postgres authentication with it. Best practices include securely manage your Radius shared secret, ensuring that that cannot be breached, and all communication in Radius should be encrypted to ensure that there is no breach for data in motion. Certificate authentication. This is very closely aligned with the encryption of data in motion that we discussed in one of our previous slides. Essentially, certificate authentication uses SSL client certificates, much like we did for data in motion. You generate an SSL certificate from an authorized vendor, and you tell Postgres to verify that certificate before it allows a client connection in. It's a very strong authentication method. It complies with pretty much all of industry standards. Even the most stringent of security regulations are complied using SSL certificates. Best practices include ensuring that your SSL certificates are maintained and renewed, and that you are protecting your SSL certificate so that there is no breach from that perspective or from that aspect. Next up, we've got PAM authentication. PAM stands for Pluggable Authentication Modules. That actually reminds me of an interesting back and forth that I had with a customer that we were working with. They were using a particular financial management system, and it had a lot of different modules, and different modules were using different databases, a mix of Postgres and MySQL. And out of curiosity, I asked them, hey, why are you using MySQL for these other modules? And I of course have a biased opinion, being a Postgres guy, but my thought was I wanted to understand why somebody would use MySQL and not Postgres for all of the modules. And I got the response, well, we use MySQL because we needed to use PAM authentication. And I was surprised to hear that response. I said, you realize that you can use PAM authentication with Postgres as well, right? And they had no idea about it. And it's just an interesting tidbit over here. If you know the kind of functionality that is offered to you by Postgres, you can leverage it to the fullest and really extract the power out of the database. So again, PAM stands for Pluggable Authentication Module, and pretty much any authentication mechanism that the OS is using, Postgres can be integrated into that using PAM. It's very flexible. It also allows for custom PAM modules. So, if you want to incorporate a two-factor authentication, you want to use Google Authenticator, you want to use LastPass Authenticator or a different authenticator of your choice, you can integrate it in there, and PAM authentication will ensure that Postgres will integrate right into it seamlessly. Best practices, like any other, make sure that the PAM modules are secure and properly configured. Make sure that PAM configuration are aligned with your organizational policies. That brings us to the end of the section on user authentication. And to summary, make sure that you understand what your existing infrastructure looks like and what kind of authentication mechanisms are already being used in your organization. Because you don't want to introduce a new mechanism, you can integrate right into your existing mechanism. Understand the possible attack vectors, the possible breach, the possible ways the hackers could possibly get into your system, and then arrange for user authentication accordingly. Ensure that you don't make development and sandbox too complicated, but also ensure that your production databases are well protected. And just, in general, follow best practices and make sure that you're protecting your personally identifiable information or your customers' personally identifiable information in your database. Third topic out of 4 is access controls. Now, in access, what is an access control? So, authentication mechanism is the guard at the gate. So it will decide whether a user is allowed into the database or not. Access controls dictate what part of the database can be accessed by this user and what this user can do to that database or to that data. Right? So it goes into the specific actions that a person can perform, and it can, even after getting access to the database, it can ensure that different users have different levels of access, and you can protect data that is sensitive and disallow unauthorized people from accessing the data, even if you want them to be able to access other parts of your database. The types of access control methods, the first one is DAC, discretionary access control. And essentially what that means is that the owner of the data or the owner of the resource decides who can access that resource, which is great. It's flexible, but it can be challenging to scale as your organization grows and as your data grows. Next up is MAC, which is mandatory access control. Excuse me, just taking a sip of water. Mandatory access control, what it does is there's a central authority that will decide what kind of access a role or a user is given, and high security environments like to have central control like that. And then you've got RBAC, which is role-based access control, in which access is assigned to roles or groups. And then individuals are given a certain role. So, it could be an administrator role, it could be a viewer role, a commenter role, a business intelligence role, a reader role. It could be defined like that. And it's easier to manage users at scale because now you're not managing individuals, you're managing roles which are broad-based. Now in Postgres, roles and privileges. What roles does is it unifies users in groups, then you can assign, like I said in the previous slide, in a role-based access mechanism, in access control, you can assign individual users to a certain role, and then those users inherit all of the permissions assigned to that particular role. Privileges define exactly what actions they can perform. You can use the grant and revoke keywords to allow them privileges for stuff like select, insert, update, etc. Now, the levels of access that you have inside of the database, at the broad level, at the highest level, you can give access at the database level. So if you give access or privileges at the database level, the user will have that same privilege across the entire database, across all schemas, across all tables, and all of the data. If you come down one level, you can also give access at the schema level over here. So it's possible for a single database to have multiple schemas, and you could choose to give a user access to a specific schema, but not a different schema. So schema one, user one may have access to schema one, but not to schema two. So that is schema level access. Schema essentially is a container, kind of like a container that contains all of the data and different objects contained within a certain logical grouping. Within the schema, you could have multiple tables, and you could also give access at the table level to a user. So within a schema, even a user could have access to one table and not have access to a different table. So you can fine tune and fine grain the access to the table, and actually not just at the table level, even at the column level. So within a table, you can give access to a particular column and prevent access from a different column. And same goes for rows. You can give access to a particular user for certain rows, and other rows the user will not have access. This is extremely powerful in order to be able to segment and partition the kind of access you're giving to your users, and to be able to fine tune what they can or what they should be able to read and what they should not be able to read. So very powerful features and very powerful fine-tuned access levels that Postgres provides over here. Other objects that you can fine-tune access to, you can give specific privileges for functions and procedures. So, you can grant or revoke on execute. So a particular user may have the permission to execute a particular function and not have the privilege to execute a different function or procedure. And in similar ways to tables, you could also secure views. It will allow you to give a very controlled interface to sensitive data, which is especially important when we're talking about personally identifiable information. Wrapping up access control, best practice is that you implement the principle of least privilege, which means that give the least amount of privilege that a user needs to carry on their functions, because you don't want to give them more access than they absolutely require, because in that case, even if it is not malicious intent, even if it is human error, they could get a mistaken access to data that they are not supposed to view or they're not supposed to take. Use roles to simplify the management of your users. Make sure that you regularly audit your privileges and you prune the privileges, because they can kind of rot in time. There's a time rot involved, and you want to make sure that you routinely keep up to date. Security patches and updates are absolutely critical. Make sure that the entire ecosystem that you're running with Postgres is patched and updated with every minor update that comes in. And also educate the users on these security best practices so they know exactly why these policies are implemented. Now, moving on to the last section of our presentation today is audit trail. Now, we have talked about encrypting data, which is making sure that even if data is stolen, it is encrypted and nobody can actually decipher it. Then we talk about allowing only certain people inside of the gate, only allowing certain people inside after authenticating them. Then after they are inside, we've talked about access controls, and we've talked about how to ensure that they can only get to certain parts of the database. Now we're going to talk about making sure that we can trace the steps and understand exactly what happened in the database, even in case something a breach takes place, in case there is access that is unauthorized or it is that is something that we were not expecting. So we want to be able to, after the fact, investigate and ensure that it doesn't happen again. And for that, we have audit trails. Now, what is auditing? Essentially, what auditing does, it records all database activities that are meaningful for our audit purposes. You can record who accessed the database, what actions they took when they accessed the database, and you can use it for security, you can use it for compliance, and you can also use it for accountability of the users of your system. There are various different tools that you could possibly use for auditing. Postgres has an inbuilt logging mechanism, and you can specify the extent of logging by setting the value of log statement in the configuration file. There are 4 possible values. By default, it is none, which means that logging is disabled. There is no logging. You can choose to use this for development environments where security is not a priority. And what it does is, it prevents the usage of disk space that logging would otherwise use, and any other performance overhead that logging will otherwise have. So, none says logging is disabled. BDL says that, if you set the log statement to BDL, it will log only data definition language statements, which means that any structural changes that are taking place in the database, if you're changing the structure of a table, of a schema, if you are adding a column, removing a column, that kind of stuff, or adding a table, etc., those are the kind of statements that are going to be logged when you set it to DDL. The third value that you can set log statement to is mod, M-O-D. And what it does, it logs not just the data definition language statements, but also the data manipulation language statements. So DDL and DML both are tracked. And what it does, it not only tracks the structural changes, it also tracks any changes in the data in the database. So inserts, updates, deletes that are taking place in the database, all of them are tracked if you set log statement to mod. You can also set log statement to all, and every single SQL statement that is executed on the database will get logged, and you'll have a very, very deep trace of everything, and you'll have a deep audit log. Another tool that is very popular for audits is PG Audit. It's an extension that provides a lot of detailed logging. There are some additional features that you can get with PG Audit that you don't get with the built-in logging functionality of Postgres. You have fine-grained control over what type of SQL statements to audit. You can have auditing at the object level. So you could choose to audit a particular table and choose not to audit a different table. And that allows for better management of performance of your database because audit does have, logging does have an overhead, and logging does have an overhead, not only in terms of performance of the database, but also in the amount of disk space that is the database is using. So fine-tuning that access, fine-tuning that logging will give you better performance management. PG Audit can also integrate with external tools, and it facilitates compliance with standards like HIPAA, GDPR, and SOC. You can also do something manual for auditing. This is outside of the built-in logging capabilities of Postgres or using PG Audit, and you can use triggers as an example for auditing. Now, what I've done over here is this is an example of a trigger function. And basically what this function does, the function is called audit log. And what it does is it inserts into audit table the username, action performed, and the timestamp that action was performed. It inserts into the audit table. And when is this function called? If you look at this particular trigger creation over here, it creates an audit trigger on the table employees. In case there is an insert, update, or delete, this function is called for each row. And what it does is it logs the user, the action that the user took, and the time the user took that action each time there was an insert, update, or delete on employees. So this is a bit of a manual way of auditing, but this can give you very fine-grained control on the exact specifics of what you want to audit without getting into a whole lot of audit logs. Something like a trigger can also give you conditional auditing. Just building on the previous slide's example, a conditional audit could be that hey, if the current user is analyst, only then insert the user action and the timestamp. Otherwise, just don't do anything. So you can get conditional auditing by writing a function like this. So it gives you a lot of flexibility like the best practices for auditing and for logging is understand your objectives, clearly define them, and audit only what you need to audit. So you minimize the overhead cost by logging. Leverage the available tools because you don't want to reinvent the wheel. And when you are logging, make it a practice to regularly review the logs because they will give you hints at any anomalies that might pop up. Just like the personally identifiable information needs to be secure in data at rest and also in motion, you want to ensure that the logs are secure as well, because logs also give an idea as to what's going on in the database, and you want to secure them much like you are securing PII. Encrypt all database connections. That will ensure that data in motion is encrypted and is undecipherable for anybody who is spying or has any malicious intent. Keep Postgres and all of its extensions up to date. This is the best practice all the time. Make sure that you are up to date with your Postgres and your security patches. And that brings us to the end of our session today. That's the QR code right here to my LinkedIn. Please, connect, and I'll be happy to respond. I generally try to be very good at responding to connections and to requests on LinkedIn. But any questions, please type them in the Q&A or the chat section of your Zoom interface. And Annie, over to you to ask me anything from the audience.
Yeah, thank you so much, Umair. So we have a few questions from the audience, starting off with the most comprehensive one. Storing PII is one thing. Do we specify whether it's HIPAA or some other regulatory info while storing, or is there any difference in storage formats between regulatory information like HIPAA and others? Are these infos to be taken care in code or at DB level?
Okay, so that is that's a very good question. And one of the things that I try and impart education on is that most of these regulations and most of these standards dictate very similar ways on how to protect information. Remember, regulations exist to ensure that the data is safe and protected. And there are best practices that the regulations advocate. So when you're storing data and when you're protecting data in Postgres, um, you don't specify to Postgres that this is HIPAA compliant data, um, but what you do is you understand the kind of security HIPAA requires, and then you store the data accordingly. So as an example, HIPAA wants to ensure that any data in motion is encrypted and that data can be accessed by authorized personnel only. So access controls are important, authentication methods are important, and TLS is extremely important. HIPAA does not require you to encrypt data on disk, even though it requires strong enforcement of access control. So in order to comply with HIPAA, you don't absolutely need to encrypt your data, although it will give you an extra layer of security. So yeah, hopefully that addresses the question.
Okay, so the next question is, does auditing cause blocking? I think this came right near the end, this question.
Does auditing cause blocking?
Yeah.
Okay, so I'm going to assume that when the person who asked this question says blocking, you're referring to role locks or acquiring exclusive locks. So I'm going to answer this question making that assumption. In case this assumption is incorrect, to the person who asked this question, please ask it again and try and clarify it. So audits do not acquire an exclusive lock on any row. What it does is that in case you are doing a triggered kind of a logging, the data is not completely committed unless the trigger is also complete. So that is the only overhead that a trigger kind of logging will create. It does not acquire an exclusive lock.
Okay. So what are the performance implications of transparent data encryption?
So what transparent data encryption does is it makes the encryption and decryption of your data seamless. So to the user, if I am sitting on a system that has data encrypted using TDE, to me, it will appear much like any other console if I have the right access to that data, right? It will appear like just like any other console. I would not be able to tell the difference. Now, the process of encrypting and decrypting does have a small overhead in performance, right? The database will need to look up the key. The database will need to authenticate and ensure that it's presenting the data to the right user, and it will need to encrypt and decrypt. But increasingly, this overhead is very small. It is usually a CPU overhead, which is a bottleneck only if the queries are aggregate queries with lots of joins in an OLAP kind of an environment. So there is an overhead, a little bit of an overhead, but increasingly the machines are so powerful that you hardly feel that overhead. And of course, in case of regulatory compliance, you want to take that overhead anyways.
Okay, So any key indicators that one should be looking for when detecting potential security breaches?
So I think that when you are looking at the logs, I think one of the things that I covered in our slides was um, you want to regularly uh, evaluate and take a look at your log files to look for anomalies. Um, I think that looking for access from users that you didn't expect to be there, looking for activity at odd hours, looking for activity in databases, in tables that you didn't expect to see any activity in. Those are the kind of things that you can watch out for. You can watch out for an increase in activity, a certain surge in activity that might indicate an attack. Uh, so keeping in view these kind of anomalies, you should be able to understand, that there is something unusual going on, and you should be able to investigate it.
Okay, so the last question is, are there any new Postgres features that you would recommend or extensions for developers that they should study, stuff like that?
So in terms of new features, Postgres does come up with new security features with pretty much every release. Um, and I think that understanding the kind of integrations that Postgres offers with existing infrastructure is important for developers because um, you don't want to reinvent the wheel. You want to make sure that if your organization has an existing verification mechanism, you use that. So ensure, understand what kind of integration Postgres has to offer, and make sure that your database is integrated with your organization. In terms of extensions and other key features, I think PG Crypto is a very important extension to keep handy for encrypting specific parts of your database. I also think that PG Audit is a very handy extension for audit trails, and you should leverage it and make sure that you are um, keeping tabs on what's going on in your database. I'd also recommend using PG stat statements, which will give you an idea of the frequency with which a particular query is being executed, and the time a particular query is taking. Again, it can potentially be helpful in understanding if there's an anomaly, if a particular statement is being executed more frequently than you would expect it to execute.
All right, then I think that is it for today. So before we conclude today's session, I want to share our upcoming webinar on reducing cloud costs by optimizing Postgres, which will be conducted on 17 July, again with Umair as our speaker. So please register. I'm sharing the link in the chat if you want to learn how to reduce costs in this economy to improve Postgres performance. Thank you once again, Umair, for this lovely session. And thank you everyone for your time and participation. Have a great day, and we look forward to seeing you all in our future webinars. Bye-bye.
Thank you, Annie. Thank you, everyone. Have a great day ahead. Bye.